It is May 11th, just after 1 o'clock p.m. Pacific time, and you are looking at a live view of the Falcon 9 rocket as it awaits liftoff from the SpaceX launch pad in approximately 12 minutes from now. Welcome to today's live webcast of the Bangabandhu Satellite 1 mission from Pad 39A at Kennedy Space Center in Florida. My name is Tom Perdario, and we're back today for attempt number 2 of our Block 5 Falcon 9 mission. As we mentioned yesterday, this is a particularly exciting launch as we have two very important milestones taking place. The first milestone is that the payload, Bangabandhu Satellite 1, will be the first official geostationary communications satellite for the nation of Bangladesh. The second milestone is that today's launch is the debut of a series of upgrades to the Falcon 9 rocket that we're calling Block 5. These upgrades are designed to allow us to reuse each Falcon 9 10 times or more, and also reduce the time of refurbishment between flights. Today's Falcon 9 will deliver Bangabandhu Satellite 1 to Geostationary Transfer Orbit, also abbreviated as GTO. Afterwards, we'll also be attempting to recover this first stage on our drone ship, Of Course I Still Love You, which is currently stationed about 340 nautical miles downrange in the Atlantic Ocean. If successful, this will mark the 25th landing of a first stage rocket for SpaceX. And with less than almost 11 minutes left to go, let's check in with Michael for a quick status update on the rocket.
Hi, I'm Michael Hammersley, a materials engineer in our avionics department, and welcome back for our second attempt of the first flight of our Block 5 Falcon 9. In the final minute of countdown yesterday, the Falcon 9 flight computer did its last series of checks, came across an abort signal from a ground system relay, and stopped the launch as the vehicle is designed to do. It turns out that this particular signal was an artifact of an earlier test sequence that was completed successfully, but did not properly reset. Keep in mind that there are 1,000 ways a launch can go wrong, and only one way it can go right, so the vehicle is designed to stop the countdown at the slightest hint of anything that seems off nominal. The team has revised this particular test sequence to avoid this problem in the future, and the rocket and payload remain in great health. So Falcon 9 rolled out to the pad with the Bangabandhu Satellite 1 payload on Wednesday evening at about 8 p.m. local time, and it went vertical yesterday at roughly 8 a.m. local time. Today we went through the launch director's go, no-go poll, held at about T-minus 2 hours. One of the several changes to Block 5 is in how we load propellants. We still use a liquid kerosene fuel called RP1, and our oxidizer is liquid oxygen. But instead of starting with our fuel load at T-minus 70 minutes, we begin loading both RP1 and liquid oxygen onto the first stage at T-minus 35 minutes. Those proceed in parallel until just a couple minutes before liftoff. We also start loading RP1 onto stage 2 at T-minus 35 minutes, but we let that complete and then add the liquid oxygen. That started at T-minus 16 minutes. So all told, that means that currently we're at about 95% full of fuel in stage 1 and 100% full in stage 2, with liquid oxygen being at 90% in stage 1 and about 60% in stage 2. So as we've mentioned before, we're also planning on recovering Falcon 9's first stage on Of Course I Still Love You, 340 nautical miles southeast of Kennedy Space Center. And we're hoping to bring you live coverage of stage 1 during its descent. Otherwise, vehicle's healthy, payload is healthy, the range is a go, and though we're watching some strong upper altitude winds and some thick cloud layers, there's nothing stopping us on the weather front from launching today.
Block 5 refers to a series of upgrades that we've made to Falcon 9 as part of our ongoing effort to make spaceflight more like commercial air travel is today. This version of Falcon 9 you can see on your screen is designed for 10 or more flights with very limited refurbishment, but should be capable of additional flights with further testing and possible additional refurbishment. Some of the changes are actually very visible in this rocket, most notably the inner stage, this raceway cover down here, and the landing legs. All of these parts used to be white, but now they're black, which is the natural color of our improved thermal protection material, which doesn't require painting like the cork that we previously used. It's highly flame resistant and also holds up better to the elements. In particular, it's hydrophobic, meaning that it repels water. In addition to these changes, we've also made changes to the 9 Merlin 1D engines at the base of the Falcon 9 rocket right down here. The thrust of these Merlin 1D engines has increased from 176,000 pound force to 190,000 pound force at sea level, which represents approximately an 8% thrust increase. We've also changed the primary thrust structure that houses the engines, which we call the octaweb down here, from a welded aluminum structure to a bolted structure. This greatly reduces the manufacturing and inspection burden and increases reliability and shortens the lead time towards production. Additional improvements have been made to the landing legs to support rapid post-landing vehicle recovery, and we've also upgraded the operational capability of components across the board. The ultimate goal of all these improvements is to be capable of relaunching a flown booster within 24 hours with minimal refurbishment. That doesn't mean that we want to fly a rocket once per day, but it means that we could if we needed to. Now at the top of this rocket is the nose cone structure at the very top. This is called the payload fairing, inside which is Bangabandhu Satellite 1, the first Bangladeshi geostationary communication satellite for the country of Bangladesh. The satellite was built by Thales Alenia Space of France and covers a wide variety of broadcast and telecommunication applications, including satellite television, internet access, and emergency communication services, and of course much more. The satellite will be operated by the Bangladesh Telecommunication Regulatory Commission, or BTRC, and is expected to last approximately 15 years on orbit. Bangabandhu Satellite 1 will stay protected inside that fairing all the way up until about 3.5 minutes into flight. The fairing protects the satellite on ascent, but once we escape Earth's atmosphere, it's no longer needed and we pop it off. We are not attempting to recover this fairing on today's mission, but it's something that we'll look forward to do in future missions. So with just about 5 minutes or 6 minutes left in the countdown, let's check in with Michael on how the rocket is doing.
We're now just inside of T-minus 6 minutes, and stage 1 and stage 2 are both almost fully loaded with 1 million pounds of kerosene fuel and liquid oxygen. At this point, both stages are just about 100% of fuel. Stage 1 is at 99% liquid oxygen and at 90% for stage 2. We'll continue topping off both stages until about T-minus 2 minutes to keep the propellants as cold and therefore as dense as possible in order to fit as much propellant onto the vehicle as we can. Around the T-minus 7 minute mark, we began our engine chill procedure. The propellants are much colder than the engines, and so it's important to get the engines to the correct temperature beforehand by slowly flowing propellant through them. Liquid oxygen in particular is so much colder that it would turn into a gas upon first contact, which would be a pretty hard start for the engine. The strongback cradle is opening and will slightly retract away from the rocket. The strongback is the structure that's standing immediately next to Falcon 9 on your screen, not the larger gray structure. It will recline more fully as Falcon 9 is lifted. And you heard the strongback lower has begun. At T-minus 3 minutes, we'll be performing an engine wiggle. That's checking the thrust vector control system to make sure that the Merlin engines will be able to properly steer Falcon 9 during ascent. And at T-minus 60 seconds, you'll hear that Falcon 9 is in startup, which means that the rocket's internal flight computers have taken over the countdown. And you can see the cradle is opening and is just finished opening on your screen there. The little arm is just beneath the fairing. One more interesting change for this mission relates to the Merlin engines themselves. In Block 4, the engines were used with a constant chamber pressure. Because engine thrust depends on both the chamber pressure and external atmospheric pressure, the Block 4 engine's thrust would slowly increase by up to 10 or 15,000 pounds per engine during ascent. For Block 5, we'll be maintaining a constant thrust of 190,000 pounds until cutoff, which means we'll actually be slowly decreasing the engine's chamber pressures over time to compensate for decreasing atmospheric pressure.
Stage 1 launch load is closed out.
Otherwise, the drone ship is on standby in the Atlantic Ocean. The payload is healthy and go for launch. The range is also go for launch. And at this point, we're inside of T-minus 3 minutes and getting pretty close to T0.
Strongback lower has ended. Strongback's at 88.2 degrees.
So let's listen in to the last couple minutes of terminal count.
Stage 2 LOX loads closed out. And Falcon 9's on internal power. Gas closeouts.
AFTS is ready for launch.
Falcon 9 is in startup.
LD go for launch.
Minus 15 seconds.
Falcon 9 is at flight pressures.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition, liftoff.
Power telemetry nominal.
And you saw Falcon 9 lift off in a beautifully clear shot there at 4:14 p.m. Eastern. At T plus 10 seconds, the thrust vector control system
Vehicle is supersonic.
tilted Falcon to begin a pitch kick maneuver to get it going sideways. You just heard that we're going supersonic, and we're about to go through max Q when the rocket's pushing hardest against the atmosphere.
Vehicle is experiencing maximum dynamic pressure.
We've successfully achieved that major milestone of every rocket launch. We're actually decreasing the thrust in our engines a little bit around the time of max Q to minimize some of those forces. Coming up about 50 seconds from now,
And back engine chill.
there will be 3 events in quick succession. The main engines will cut off, the 2 stages will separate, and the second stage will start its Merlin vacuum engine, which you heard is just beginning its own chill procedure. Cutoff happening just a few seconds from now.